Hi everyone, myself Dr. S. Savita, Assistant Professor, Department of Physics, K.S.Rangasamy College of Technology, Trichankodu. Today we will discuss Model 1 of Physics for Textile Technology, which deals with laser technology. Now I will be explaining the basic principle of laser, their properties, process involved in laser action, the components required, different types of laser. This is a very important topic because lasers are widely used in science, engineering, medicine, and also in textile technology for cutting, designing, and processing materials. The laser is nothing but light amplification by stimulated emission of radiation. Unlike ordinary light sources such as bulbs or sunlight, laser produce a high intensity beam of light with monochromatic nature. These properties make lasers are very special. For example, sunlight spreads in all directions and contains many colors, but laser pointer gives a single short beam that travels straight manner. This difference is what makes lasers are very useful in technology. Now let us see the properties of light. Laser light is a very different from normal light because of having its unique properties. That are all the monochromaticity, coherence, directionality and high intensity. Now let us these all properties in brief manner. First one is a monochromaticity. It is a only one wavelength or one color. For example, a red laser pointer emits only red light of a specific wavelength. And second one is a coherence. It's a very important property involved in laser. That means that light waves travel in same phase. That means all the light beams are having a same frequency, same wavelength. That means everything are in same phase. This means they rise and fall together, making the highly light beam of with the highly order. And next one is a directionality. The beam is very narrow and does not spread out like torchlight or sunlight. Even after traveling a long distance, it stays focused. And fourth one is a high intensity because of having a high directionality property that light beams will concentrate in one direction. The beam is very powerful. For example, even a smaller laser pointer can be seen clearly at a distance. These four properties makes laser suitable for applications like surgery, communication, cutting materials and scientific research. Now let us see the process involved in laser. Here the laser action depends on three basic processes: stimulated absorption, spontaneous emission and third one is stimulated emission. Now let us see all these three processes in brief manner. First one is a stimulated absorption. Here the atoms are absorb energy from an external source and jump to higher energy level. Normally in our universe, every atom naturally prefers to stay in its resting or ground state. That we know that. When energy is given from outside source, the atom gets excited and moves to a higher state. But it can't stay for a long. After a short time, it always tries to come back its original resting place, and while doing so, it releases the extra energy that it had absorbed. So based on this only the emission is happening, and second one is a spontaneous emission. After some time the excited atom return to the ground state and it releasing photons randomly without any external triggering forces. And third one is a very important one. It's a stimulated emission and this is a very special process when a photon of a particular energy strikes an excited atom and the atom release another photon exactly like same energy, phase and direction. This process is continuously keep on happening. That means the atom absorb energy, get excited, release the absorb energy and trigger others in continuous chain-like process. That's why lasers are very powerful and precious. For getting a powerful of laser output, the population inversion is very important. That means without population inversion, laser action can't happen. For a laser to work, we need a special condition. That means the number of atoms in the excited state should be greater than the number of atoms in the ground state. Normally in any material, more atoms are in ground state compared to the excited state. But in laser, we make more atoms stay in excited state than the ground state. This process is called population inversion because it's very important. If most atoms are in the ground state means the absorption will dominate. But if the atoms are in excited state means then the stimulated emission will dominate, and that is what produces the laser high intensity laser beam of light. Now let us see the basic components of laser. Here the laser has three essential components. First one is the energy source, which is used to provide the energy to excite atoms into higher energy level. For example, the flash lamps, electrical current. And next one is the active medium. Here the material where the amplification happens. That means that population inversion happens. It may be a solid, liquid, gas, or semiconductor. And third one is the optical resonator. It contains two mirrors which are placed at the end of the active medium. One mirror is a fully reflective mirror and another mirror is a partially reflective mirror. These three together form a basic working system of all lasers. Now let us see the types of laser. Lasers are classified based on the material used as the active medium. And first one is a solid state laser. The best example of solid state laser is a ruby laser and NDYAG laser. We can also call it as a neodymium yttrium aluminum garnet laser. And next one is a gas laser. We know that carbon dioxide laser, helium laser is the best example of gas lasers. And liquid lasers, we can consider any liquid organic dyes means we can consider that as a liquid lasers. And fourth one is a semiconductor laser. Here the diode lasers are used in CD, DVD players, laser printers and optical communication also. Each type has a different wavelength and application. For example, gas lasers are a good for precise alignment while solid state lasers are used for powerful application like cutting and welding. Lasers are special light sources that produce a very focused and powerful beam. They work based on the idea of stimulated emission, which makes the light pure and precious. Because of these properties, lasers are used in many fields like medicine, communication and manufacturing. They help make a task faster, more accurate and efficient. Lasers have already changed the way we work and live in many ways. As technology advances, laser will continue to bring exciting possibility for the future. Here, these questions are based on the material we just went through in slides. Try to recall the key points before answering.